So my name's Claire Lewis. I actually work for Vistion, but I'm also the project lead for the UK CITE project. What I'd like to do today is to give you an overview of a project, what it is and where we are today. And then afterwards I'm going to hand over to Andrew Patterson from Mentor. Although Mentor are not one of the consortium partners, excuse me, they are one of the technology partners of Vistion on this project. Okay, so what is the project? So this is a 2.5-year project, partly funded by CCAV through Innovate UK and also by HE. We've got 11 partners covering the infrastructure, the telecoms providers, academia and the vehicle technology providers. During the project we'll be looking at different types of communication technologies, testing them back to back and looking at their performance and appropriateness for different types of messaging on both HE roads and Coventry City Council roads. Okay, so this is a matrix explaining what we're going to test. So we're going to look at different types of messaging, which are across here. So we'll be looking at safety messaging, autonomous messaging, and then looking at which of the technologies is most appropriate according to the latency requirements and the distance and accuracy. We'll also be looking at how that messaging is actually displayed in the vehicle, trying to cover all those vehicles from those that have high levels of embedded technology with embedded displays and instrument clusters to those that have nothing. And what we want to try to do is to get the benefits of V2X to as high a percentage of the road users as possible. So whether it's through embedded systems or whether it's through a mobile app, that's what we'll be looking at in the project. You'll notice here we've actually got MEC on there as a network provider. We're not actually looking at mobile edge compute, but it's something that has come to the surface during the project that we might explore at a later date. Okay, these are the work packages. So we split it into 11 work packages led by different members of the consortium. Some of the work packages are worthy of a project in themselves. So the cybersecurity one, for instance, is worthy of a project. So for cybersecurity, I wouldn't say we're scratching the surface, but we're doing what we can to support this project. So we've come up with some procedures to support the CITE project, and then we'll be making recommendations afterwards to go on to further projects. Okay, so the 4 use cases, it's quite a large consortium and it took us quite a long time to come to a decision on which use cases we were going to work on. So we ended up choosing 4 to try and get us moving and then choosing another 4 later. Some of them have existing car-to-car triggering points and others don't. The first 4 we've actually now completed. They've been bench tested and we're about to start track testing, and then the second 4 are in development. The last 2, cooperative ACC and lane merge assist, are technically very challenging in the time frame that we have, but we're going to do as much as we can on those, but they will only be tested on track and not on road. Okay, so this diagram here, this architecture diagram, is what Martin calls his noddy description of the architecture. And I'm not going to explain it all, but this section here is the infrastructure, and this is the vehicle. That's about as far as I'm going to go with that. We have actually one thing worth mentioning, because Innovate UK are keen to get exploitation of projects which go on to other projects. In the right-hand corner there, we've got a mobility app server, and that's building on a platform that we developed with the University of Essex and Essex County Council. It's using the same platform that we developed there under an Innovate UK grant, and that is now sort of fed into here. If you look at the vehicle outside, it's actually got this section in it, and it's got this as well, so please take a look. Okay, we've actually got 4 vehicles kitted out, 3 JLR vehicles and our Ford Focus outside. Each of the vehicles has this onboard unit in it, and 2 of the JLR vehicles have also got pre-standard LTEV on them as well, so we'll be testing that. Okay, so this is the test route. So it's a combination of HE roads, which is the M42 and the M40, and Coventry City Council roads, which is the A45 and A46. So we'll be using a combination of ITS-G5 and LTE on the roads. And where you see the grey sections, we have no coverage of ITS-G5, not because we don't want it, but there's no power there. And to put power in is quite expensive. But it will be a good test of reality, because when we actually get connected cars, there will be gaps in the connectivity, and we need to know how the onboard unit will cope with those gaps. And then at JLR, on the test track at Gaydon, we've got ITS-G5 and LTEV. So we'll be doing back-to-back testing there, and that testing actually started yesterday. So the infrastructure started to be installed in May this year. It's a 40-kilometre route. We've already got 22 roadside units in Coventry, and they've conducted a test on one of those sites. They're currently putting the poles and antennas onto the M42, and about 60% there, and then we'll start to put the roadside units in. This portion at the bottom, so HE and Coventry City Council and Siemens have put together a provisional code of connection, so that not only the consortium members can use the network, but other users as well. And this just shows the blue areas are where the roadside units are, and where you see a big gap in the roadside units is where we have no power. Okay, vehicles. So we aim to test just over 100 vehicles with different levels of technology in them. So we'll be testing the fully kitted out vehicles, so they have the Visteon onboard units and embedded displays. We're also going to test some vehicles that just have the mobile app. So they'll receive messaging into the car from the network, but on a mobile device. And then we're also going to do some testing using the OBD2 port, again on the JLR vehicles. So JLR will be coordinating stage 1 and stage 3, and Coventry University, because we want to look at the behaviours of the drivers as well, are going to coordinate stage 2. So challenges so far, it is a large consortium, but I think we now, after just over 1 year, we do have a very good understanding of how each of the partners works, and that's been quite beneficial. Trying to make sure that the project stays on track and not redundant has been quite a task, and that has led to us sometimes having a bit of scope creep, and I have to rein everybody back in. So we've had some very good ideas for parallel projects, and we need to put those to one side and work out a way to work on them, but not work on them in the main project. The power gaps in the network, I've already spoken about. LTEV has been a bit of a problem for us, because it hasn't been clear when the LTEV R14 release will be available for us to use. So we've now made a decision to go with pre-standard LTEV and do as much testing as we can. And when and if the R14 is available, then we're going to try and substitute it back into the architecture. And we have had some hardware issues. Ironically, we chose to use development kits to try and reduce the risk of having new software and new hardware. Unfortunately, the development kits went wrong, so it didn't really take away the risk. Okay, just some key dates for you. So the key date that's on us now is the start of the track testing, which started Monday. And we will start road testing before the infrastructure is complete. Again, it's useful for us to see what happens when we lose connection and when we have to switch from one communication technology to another. And we intend to have a phase 1 demo sometime around the end of this year, early next year. So that will be the first 4 use cases. And the infrastructure will be complete 2018. And although the project finishes in Q4 2018, we have commitment from HE that the network is going to be available for at least 2 years afterwards. So it will be open for other users to come and trial connected vehicles. So that's it for me. I'm going to hand over to Andrew. Oh, there he is. And Andrew is going to explain a little bit more about what Mentor are doing for Vistion on this project. Thanks.
Good afternoon. My name's Andrew Patterson from Mentor. Many of you may know Mentor as a tool provider, and indeed we are. We're actually now part of Siemens PLM. It's a sister company to Siemens Mobility, who are working on this project as well. But actually I'm part of the embedded software part of Mentor, and we've worked as a partner with Vistion on this project to provide some in-car embedded technology. I'll try and give you a little bit more background on that. There have been quite a few technical challenges. The communications links and coverage of the network, which has already been described. Latency, low latency, was a very important point in this project. So we wanted the messages to be rendered in the driver's consciousness really quickly, if anything happened on the road or outside the vehicle. Part of the trials will test bandwidth and network capacity. What happens when there are many, many vehicles with this technology. We've implemented a few safety features, in particular a heartbeat, so we can ping the vehicle and check it's still there, it's still alive. We're hoping as Mentor we can help with the deployment, awareness, adoption of this technology, not just in the UK but perhaps further afield. And there are some softer issues that people sometimes ask us about, privacy, security. If you have access to my in-car systems, will I still have control over that data? Who uses it and who has access to it? So those are some of the technical and political issues we've had to consider. As Claire described, if you can distill the complex or even the noddy architecture diagram down, there are really three communication channels that we have implemented in the system. The first is the DSRC, Dedicated Short Range Communication, 5.9 gigahertz. It's been reserved for V2X channels and V2X communication, as many of you know. We've also tried to make use of something which everybody, I'm sure, in this room has, which is a cell phone, and leverage smartphone connectivity. And thirdly, we've leveraged Wi-Fi connectivity, ubiquitously used and generally available, not so much on roadside equipment, but certainly a technology that could work on some dedicated highways. The Vistion onboard unit can decipher the best connection from those three available medium, and then we take that communication and present it to the driver or passengers in the vehicle. The architecture is shown on this slide. We tried where we could to make use of industry standards to help with adoption. Whoops, it's on auto advance there. So we picked a Geneva Linux core operating system. Geneva, if you don't know it, was a consortium set up to try and standardize infotainment operating systems. And Mentor took Geneva and added some additional IP layers on it. Any of you that have used Linux will know it takes a long time to boot up. That's generally not acceptable in an automotive environment, so we've optimized the boot time. We've added additional IP layers to improve graphics, audio, performance. This particular Linux has a Qt framework. Qt is a UI technology. We picked it because it's open source, and we set up in the initial trial system a relatively simple infotainment screen, which you can see at the top there, written in Qt. We've got some more complex examples on our demo booth outside, so do come and take a look if you'd like to. The routing for the messages on this diagram can take two different paths. One is through our Paul's technology that you heard about earlier, the Siemens Roadside Unit. That uses that receives information from the Highways Agency, and it then transmits it to the Visteon onboard unit. We're actually listening to two different virtual ports. One is a regular port, which would carry regular internet, Ethernet traffic, navigation information, and we set up a high priority port for the V2X messages. So imagine if there was a braking event 200 meters ahead, we would want that message to come through really quickly to the driver. So that's on a high priority port. It gets monitored continuously, and then that information would be rendered on the screen with very low latency. We've also shared the information on Visteon head-up displays on Visteon clusters, so there's no excuse for the driver missing this message, we hope. The other connection path we've tried to enable is through cellular connections. Again, we took a relatively industry standard connection method called MirrorLink. What MirrorLink allows you to do is to display whatever is on your cell phone onto the car head unit. So it's a nice way of getting cell phone information onto the driver screen. I'm sure this will evolve as the project moves forward. This was a part of phase one. So part of phase two, as was mentioned on one of the earlier slides, was to add, for example, multi-lane gantry display, add further information relating to the car's position. Often the message will be context specific. You may want a different message depending on what lane of the motorway you're traveling in. Testing has been really important in this project. The trials are starting on the real roads now, but we had to start testing a lot earlier. We actually developed an emulator which could model the highways cloud, so we could send test messages to the in-car units. And this is also running outside, and we use this to load test the system, to test different message displays, get the format right, the ability to display different text strings, and the industry standard message formats. Going forward, we hope we can promote this to a wider audience together with Visteon. The complexity of infotainment panels is increasing all the time, and on this screen you can see a couple of other examples: high resolution screens, a lot of data density, data sharing around the vehicle, and our continuing partnership with Visteon and Siemens Mobility, we hope will help promote global awareness on this. If you'd like to see any of this, do check out the Visteon car outside. The Mentor booth outside also has these demonstrations running. Thank you for listening. Thank you.